I've just come from an absolutely fabulous session on AI, and I understand there was a really terrific session in here on rules as code and AI. And we're going to really continue that theme of focusing on, in these two sessions, focusing on how technology can assist us in legislative drafting. We might do the two sessions sort of straight after each other. In the first one, we have Michael Fairweather from Mind Solutions, who will be talking to us about legislative quality assurance by computer simulation, and that'll probably be about a half-hour discussion or half-hour presentation from Michael. And then we'll move into a recording from Matthew Waddington of the Legislative Drafting Office of the Channel Islands, who'll be giving us an update on computer-readable legislation project. We'll probably, at the end of that, have maybe 10 or so minutes, assuming we can go a little bit into lunch, Jeff, or maybe we might have slightly fewer minutes to ask any questions of Michael and Matthew. And we'll also be joined in a Teams meeting by Meng Wong from Singapore Management University, and Meng also established Legalese. So if we could please welcome Michael on legislative quality assurance by computer simulation.
Thanks very much, Meredith, and hi everybody. It's great to see us all reuniting to one track. I'm going to talk about how using computer simulation can improve the quality, the utility and the accessibility of the legislation that you draft. I've got a lot of material to cover, so I'm going to go very quickly, and hopefully we can cover some questions at the end. But the three techniques that I'm going to talk about are firstly testing legislation in a spreadsheet, and then I'll move on to automating legislation in an expert system, and then finally I'll show a fully fledged simulation in an integrated development environment, or IDE. Now, the example law that I'm going to use for all three techniques is the infamous Dog Act. Now, that's, I believe, is a sort of a standard go-to example of any act. This is not a fictitious act, though. This is the West Australian Dog Act, 1976. Here's how it looked when it was passed. Apparently, it was just called Dog at the time. No one knows why. But now it stands at 101 pages in its current consolidated form. The structure of it is quite typical of any other act. It's broken into parts, including things like administration, registration of dogs, keeping of dogs, control of dogs, enforcement, civil remedies, local laws, etc. This part 6A was added quite recently to prevent puppy farming. So it's had some amendments over the years. This is the current form, which I'll be using for these three techniques. And the starting provision that I'll use is section 33D around dog attacks. Now, I won't read out every word, of course, because you can see it on the screen, but we do need to understand how this works, because the logic of it will be important. So basically, if a dog attacks or chases someone and causes physical injury to them, then the owner or other people liable for the control of the dog are liable or commit an offence. Okay, the penalty, if it's a dangerous dog, is $20,000, or for a non-dangerous dog, it's $10,000, or at least that's the maximum. And then the second provision is that if the same thing happens without causing physical injury, then the penalties are $10,000 for a dangerous dog or $3,000 for a non-dangerous dog. Okay, so I've skipped some detail there, but that's roughly how the provision works. It creates this offence and it applies these penalties. Now, used are these terms attack and dangerous dog. They are defined in section 3. A dangerous dog is one that has been declared dangerous or is of a restricted breed or is a commercial security dog. And regulations under the Dog Act actually do prescribe what the restricted breeds are. My favourite one is the Dogo Argentino up top there. I've never come across one myself, probably a good thing. And then an attack is defined as behaviour which is not induced by provocation, but which does include things like aggressively rushing, harassing, biting, tearing clothes, or behaving in a way toward a person that the dog is that would cause a reasonable person to fear physical injury, unless the owner can establish that the behaviour was justified by a reasonable cause. Okay? And then the final definition is of provocation, which is, in the case of a person doing the provoking, it's teasing, tormenting, abusing a dog, acting cruelly towards, unlawful entrance into premises of the owner or the dog, intrusion into a vehicle, or a threat upon a person that the dog is expected to be protective of. And if it's another animal doing the provoking, it's basically just those three things: an attack on the dog, unauthorized entry, or the threat towards a person that the dog is expected to be protective. But there's one final proviso, which is that it's not an intentional provocation of the dog by a person who is liable for controlling the dog, for obvious reasons. Okay, so what we've kind of got here is this model, this tree diagram where we've got linked rules and dependencies. You can see that there is an offence item there, which is only determined in the case of chasing or an attack. And then an attack depends on these things below, like rushing, biting, tearing clothes. But it also depends on there not being provocation. And then provocation is defined as any of those things below, but not the last one, intentional by a controller. And then the penalty, of course, depends on there being an offence, and then the penalty depends on whether there was injury caused and whether the dog is considered a dangerous dog, which partly depends on whether the breed of the dog is a restricted breed. Okay, so hopefully you can see how this diagram kind of comes together and links back to the clauses, or the sections. The first provision provides this. The second, this. The regulations provide this. The definition of an attack is here, and the definition of provocation is here. But it doesn't really matter, because once we've built the model, it really just operates as one model. Okay, so we need some scenarios. John's pet pit bull terrier Rex bites someone in the park for no reason, causing lacerations and bruising. And I happened to be there when that happened, and I got a photo of it. It looked something like this. And then the next day, his poodle, Betty, rushes at someone that is teasing her at the grooming salon. Okay? This is out of character because she's never been declared dangerous. I wasn't there, but I believe it looked something like this. And I think it's actually the same person, so maybe he was getting his revenge the next day. So the first technique is the spreadsheet analysis. I've created this model in Microsoft Excel. There are rules and formulas for each of the inferred fields in the model, which are the ones in orange. But I need to input the values in the blue fields as the inputs to the model. Okay, so you'll see the formula for penalty looks something like this. You see all the ifs and the ands and the numbers. The formula for offence looks like this. The formula for dangerous dog looks like this. For attack, it looks like this. And for provocation, it looks like this. So you've all used Excel before, you get an idea for how these formulas work. Let's put our first scenario in. The breed of the dog was a pit bull terrier. So we'll select that there. There was biting involved, so we have to select this one to be true. And then there was no provocation in this case, but there was physical injury caused to a person or animal. So we set that to true, and we see up top there has been an offence, and the penalty is $20,000. Okay? So we've tested that first scenario in our spreadsheet. We'll go on to the second scenario, and in this case we've got a poodle. It's not on the list, so we just choose other. There was rushing at involved, so we have to choose this item to be true. But remember, in this case there was provocation, so we find the teasing question and answer that as true. And you can see now the penalty has gone from 3,000 to 0, and the offence committed has gone from true to false. Okay, so we've tried the two different scenarios within the same sheet, within the same spreadsheet model. Okay, moving right along, expert systems. Now, you don't have to get very far into the administration section of the Act to find concepts like local government, occupier, premises. Okay, so now you can kind of see we're living in the real world. We've got these different entities in our domain that we have to take into account when we build a model. It's not just a case of one dog, one person, one incident like we had in the first model. So what we do is we build a data model, okay? Because these things like breed and cause injury, they're really properties of entities, okay? Breed is a property of dog, whereas caused injury is a property of incident. The breed of the dog doesn't change from one incident to the next, whereas whether or not injury was caused can change between incidents, okay? So these are the sort of the inherent characteristics of the entities. Then we can add the inferred characteristics or properties. But importantly, we have relationships between them. Okay, so for example, a local government registers many dogs, but any one dog should only be registered with one local government. Okay. Likewise, a dog probably just has one owner, but a person can own multiple dogs. Okay, so that's sort of how these relationships work. So then how do we build a model for this? This is Oracle Policy Modeling. It's a platform that's used to build expert systems. If I go to the Data tab here in the model that I've built, you'll see those same entities, like dog, including dog's breed, person, and you can see that the person has a list of dogs down here. That's how they link together. And then there's also an entity for incident, including all of those questions around the parameters of the incident. Also on the Rules tab, you can see two documents. There's a Word document and an Excel document. This is the rules in the Word document. I'm going to show you them side by side with the original provisions. And this is the definition of provocation, as shown on the right in the Oracle Policy Model. Okay, so you can see it's quite natural language. It also follows the same kind of structure as the underlying definition. We call this isomorphic, right? So same shape, same language, to the extent possible. And to be clear, the language on the right is, although it's human readable, it's still very much machine executable. Okay? And that's really the point. Very quickly, here are the definitions of dangerous dog and attack. Here is the list of restricted breeds. This is actually in that Excel document that I showed. Not to be confused with the Excel sheet which we saw before. This Excel has no formulas in it. It's just a way of listing out things like a lookup table, basically. And finally, the main provision and the provision for the penalty amount. Admittedly, the OPM rules don't look as similar to the underlying legislation as did the other ones. But in reality, that's how we have to write the rules, because we have this data model. So a person commits an offence if for one of their dogs, and then for one of the dog's incidents, the incident resulted in an offence. It starts to become a little bit less natural to say in English, but again, that's what matches the model, so we can have this more rich automation of the scheme, as compared to a sort of more linear Excel or spreadsheet testing version. And then the penalties are listed there with the different permutations on the right, depending on whether the dog is dangerous and whether there was physical injury. So how do we run the model? Well, back in OPM, I'll click on the debug button here, and then it'll open the OPM debugger, where I can now create a scenario. And this is, again, allows for a more rich sort of test case, because we can have multiple dogs, multiple incidents, and so on. I'll go ahead and start by adding a person. So let's add John, first of all. There's not many properties of person in this model, it's really just his name. Then I'll go on and create two instances of dog. The first one is Rex, who is not a commercial security dog, hasn't been declared dangerous as far as we know, but is a pit bull terrier, so will be inferred as dangerous, which we'll see just now. Okay. And let's go ahead and create Betty as well, who is also not a commercial security dog, we know has not been declared dangerous, and who is a poodle, and so she will not be inferred as being a dangerous dog. There we go. And now we're ready to create the incidents. So we'll assign those two dogs to John. So Rex and Betty belong to John. That's important to create the connection. And now we can create the incidents. The first incident was the bite in the park. So the dog involved in the incident was Rex. So I can say that he was the one in the incident. And just for the sake of time, I'll set all of these other attributes of the incident to false, and then we'll just find the couple that we need to set to true. So Rex was involved in biting, and physical injury was caused to the victim. We've already found out now that there was an offence and that the penalty is $20,000. If I right-click and ask to show the decision, I can now get a hierarchical explanation of how that was reached. All in natural language, easy to follow. So if there's a result that you don't expect, you can quite easily see where the reasoning doesn't match your own reasoning. Okay. Let's set up the second incident for completeness. This one involved Betty. And again, we'll set everything to false and then just find the relevant attributes to set to true, which, as you remember, she was rushing at or harassing someone at the salon, but it was invoked by teasing or tormenting or abusing the dog. So we'll set that to true, and we get the same result as we expected. There was no offence, and the penalty amount is 0. Again, we can see the reasoning for that, and it's a little bit shorter of an explanation because there were less steps required to reach that conclusion. Okay, so I want to just add a little plug here now to L4. This is what you'll see in the next session. It's a language that was written by the Singapore Management University and Legalese. I've been collaborating with them quite a lot recently. But in the L4 language, this portion of the provocation definition looks like this. So you can follow the language and the structure a little bit, but it is kind of in a codey environment. But you can create these visualizations, and you'll see more of that from Matthew in the next session. So finally, the third technique is to create a simulation in a Java-based IDE. And the reason we need to do that is because we've got this model, and it's great as a functional model. You can put inputs in, get outputs out, but you can't really model events. Okay? So in the life of a dog, certain things happen. They are born, they are hopefully registered, they can be transferred from one owner to another, they might mate, they might have an incident, and eventually they will die, unfortunately. And so all of these different events have legislative consequences. So they have consequences that are anticipated by the Act, which we need to be able to model, to be able to fully test the whole scheme in operation. We have the same data model as we had before. I've just rearranged it on the screen, but what we now introduce is this sort of overlord dog act world class, right? Kind of like the simulation master, maybe a bit like the Truman Show with Jim Carrey, where they have the console and it's controlling the sun and the rain and everything. And it's in this class that we generate these events, like creating a new dog by mating, and so on. And then the parameters that I've used for the simulation is that every day, which represents a cycle in the simulation, there's a 1% chance of a new puppy being born. There's 0.5% chance of a dog being transferred, 1% chance of an incident, and 1% chance of a death. I didn't want to include the last one, but I ran a simulation without that, and of course the dog population got out of control, started taking over the whole world, and so, just to be fair. And then every time there's a birth, there's an 80% chance that the birth will be registered, even though it should be registered 100% of the time. And then likewise, when dogs are transferred, they should be registered, the transfer should be registered, but probably only happens around 70% of the time, let's say. So the platform that I use for these simulations is called Greenfoot. It was developed by King's College London and others. It's supported by Oracle because it uses the Java language, which since Oracle's acquisition of Sun Microsystems has become kind of an Oracle technology, even though Java itself is open source. Okay. And you'll see I've got these classes on the right, including the dog act world, but also including classes for each of the actors: dog, local government, person, and premises. Okay. Now here in the middle of the screen, we can start to set up a simulation. Okay. So I've decided that there should be 5 people, 2 local governments, 4 premises and 10 dogs. They're sort of scattered in the middle of the page. And then when I click on Act, it will run one cycle, and it'll set the relationships between them. So the red lines represent dog ownership, the pink lines represent dog registration, right, between a dog and a local government, and the other lines mean other things. And you can see we're on day 1 in the top left there. Now if I click on Run, we actually start to go through the days. You saw some relationships change there. I can also hover on the objects and get more information about each one. And I can also then see the relations between the objects being enhanced. And then eventually the simulation, I'm speeding it up now, so now we're seeing more changes to the instances and also the relationships. And what's important is that all the time, while this visualization is going on, every event is being tracked. So this is the terminal window, but basically there's a kind of a log of all the events that happen during the simulation. And I can drill in and kind of investigate what's happened during the simulation. So, for example, puppy 12, there was a puppy created, puppy 12. It was transferred from person 5 to person 4. The transfer was reported to City Council B, and then there was an incident on day 900, and so on. Okay, so everything is tracked so that you can go back and kind of explore what happened and possibly identify cases where there are unintended outcomes. Now, the problem with the simulation is that it's written in Java, which is a technical software language, less accessible to legal drafters than, say, Oracle Policy Modeling. So if we compare the three, we've got the Excel formula, we've got the OPM model, and we've got the Java method down the bottom. It's pretty easy to see that the OPM language is more human readable than the other two. So what we can do is we can have the best of both worlds. You as the legal drafter and me as the LQA consultant can build the Oracle Policy Model, and then in the background, with some help from generative AI, which I'm not otherwise going to talk about in this session, we can build a model that will run a simulation, but then part of that simulation can pass a random incident and the random parameters of that to the Oracle model, who will then respond with the outcome. Yes, it was an offence and the penalty is $20,000. And then continue on with the simulation. So I know I've covered that pretty quickly, but hopefully you can see how you get the best of both worlds. You can still do a lot of the modelling in the human readable form, but then still have all the power of the full simulation in the Greenfield environment. And so what happens if a dog attacks its owner? Now, I didn't think about this. The only way it came up is because a dog in the simulation attacked its owner. Now, according to my interpretation of the law, the dog owner is equally liable for the penalties as they would be whether or not they are the victim of the attack. I don't know if that's the intention, but it's a question that was raised in insight by running the simulation. In practice, it might not come up because probably you wouldn't report an attack. You might not want to keep the dog, but you don't want to go and give $20,000 to the local government just by volunteering the information. And it's important because there's a provision that says an authorised third person can order the destruction of the dog. Okay. So finally, when we come to why doing this sort of thing, hopefully you can see that you can get insights and improve the quality of the legislation, or at least your confidence in the operation of the legislation. But the big bonus that you get is that you've created an executable model of the law, which can then be used downstream. So in this case, it would be local governments. They can use it in their internal systems for like dog controllers or registration officers, but can also be used on local website. So members of the public, if they get bitten in the park, they can go on and see what the consequences are of that. So really quickly, that public website might look like this because I've set up these couple of screens to just collect all of the relevant information. And then when we run it, imagine this now on a public website where a user just selects the dog's breed, answers all the other questions that we've already seen in other testing environments, and then get the same outcome as we did when we were testing it. Okay, it also has the explanations, so the user can see how the decision was reached, and this can and probably should refer back to the actual clauses of the Act. Same thing for the penalty. And so the idea is that the model that you create is useful for testing purposes at the drafting stage, possibly even at the policy making stage, or maybe at the point of cabinet approval is when we kind of come in and start to build something like this. But that model can then be used by the same, probably the same agency that's instructing you in the first place, right? Why should it be different? Why should we have to kind of write it twice? So the second scenario has come out with a different result, but in the same kind of form. There was no attack, there was no offence, and there was no penalty. Okay, and we've built systems like this for 43 agencies in 12 countries over 15 years. The problem is there's not one legal drafting office on the screen. So I'm looking for a foundation customer to work with to build these models up front for downstream consumption. Anyway, it's starting to sound like a sales pitch, so I'll leave it there. Thank you very much.